No, there was not. All right, so 5.7, apply the fundamental theorem of algebra. Alright, so probably what I'm going to do is I'll probably do all the notes first, and then I'll like stop the video and start again, so that way next year if I do end up having them do this as notes, then it just, our schedule, the way it was going to work out, it just made more sense for me just to do it, and rather than like make you guys watch it, just because of it being a Thursday. But anyways, let's see. So if we had a problem like x cubed minus 5x squared minus 8x plus 48 is equal to 0, then this would, I'm not going to show all the steps, but this would factor into x plus 3 and then x minus 4 squared is equal to 0. So it'd factor into this. So there are what we call two distinct solutions. Which would be -3 and 4. Okay, we set each of these pieces equal to 0 and solve for them. Okay, you get -3 and 4. But remember how before I said sometimes you might actually have like a double zero or a repeated solution? I kind of mentioned those before. Now we actually do have that. So a repeated solution is a solution that gets counted more than once. So in this case, all the solutions would be -3, 4, and 4. Okay, 4 was a repeated solution in this case because that term was squared. Okay. Awesome. All right. Theorem time. What color do I want to do theorems in? Red. All right. The fundamental theorem of algebra. All right, so the fundamental theorem of algebra, there's a theorem and a corollary, so we're going to write the theorem first. It's like part of the theorem that's like in addition to it, kind of, I guess, is a kind of a simple way to explain what it is. It'll make more sense once you see the two things written out. All right, so the theorem says that if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x is equal to 0 has at least one solution in the set of complex numbers. Okay, complex numbers meaning what? I's, yes, I's. Like the power that it's being raised to. Like x to the 4th is degree 4. Like if I had x to the 4th, the degree would be 4. So that degree n is just whatever that power is. Yeah, it's fine. Well, and yesterday in pre-cal we talked about Chesapeake Chuck, so that was like a whole 5-minute segment of my video in pre-cal yesterday. Yeah. Well, like my college professor would record everything. He had like a little video camera, so somebody in the back had to like record everything that he did, and like he would literally be like, "Okay, I need to edit that," because he's like, "I can't put that online." And I was like, "Okay, we probably shouldn't be talking about that then." All right. Then the corollary, if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x is equal to 0 has exactly n solutions provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3 solutions. And just so this doesn't take forever, and so on. Yes. So it's saying whatever that number is, that's how many solutions there are. Yes. But like some of the problems that we've been doing, it's been a problem that's raised to the 5th, but there were only 2 that we saw. But what is possible is that they were repeated 2 or 3 times, or there might have been a complex one. So this is just an extension of the last section, basically. Okay, so if it were to ask you how many solutions does the equation have, the number of solutions is whatever the highest power is. I literally just grabbed another red marker. Yes. So actually here, I'm going to write one more thing underneath here that just like helps. This also, okay, this right here, this corollary also implies that an nth degree, okay, just meaning that power, polynomial function f has exactly n zeros. Okay, so however many solutions it has, that's how many zeros it has, is basically what this means.
What does the f mean?
The function f, like f of x. That's like the most common thing that people just like freak out over, and it's like it's nothing, it's just y. It doesn't make sense until they see function notation. The number of solutions, just so y'all have this written down, is equal to, okay, this is obviously what the theorem says, but just so this makes more sense. The number of solutions is equal to the highest power of x. So, for example, x to the 5th plus 3x cubed minus 2x plus 1 would have 5 solutions.
Some of them should be going to the eyeballs.
Yes, with the eyeballs, yes.
Okay, don't think of any other stupid or
I'm debating what I want to do. I'm just debating what I want to do next. Did I miss? Is this theorem in this section? Well, I was debating if I wanted to do an example or if I wanted to finish doing the notes, but I think we're going to finish doing the notes because there's just a lot of them and they just need to be done. So. All right, so the next thing, complex conjugates theorem. Oh, there's a lot. All right, this theorem says that if f is a polynomial function with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. Okay, and this also is true in the other direction. If a minus bi is 1, then a plus bi is 1. Like not an I. Just like 2, -7, things like that. What is your question? Like A and B are coefficients. But I is obviously making that, and I is an imaginary number, so it's making that a complex number altogether. The real part and the imaginary part. A is real, BI is imaginary. Alright, then we've got the irrational conjugates theorem. Alright, suppose f is a polynomial function with rational coefficients pretty much any number is real unless it's like imaginary. Like, I know that sounds stupid, but like that's true. Like if it's not an I, it's real. Okay, because the poster maybe will help it make sense a little bit up there, the little pi guy being like get real, and then the square root of -1 says be rational. A rational number either it doesn't repeat, so it like comes to an end. An irrational number does not ever repeat. Like the square root of 2 is irrational, pi is irrational. Because it just keeps going to infinity. It never repeats. Okay, wait. Yes. 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 Yeah. Yeah. It keeps going and it doesn't repeat. It doesn't repeat or end. So it's irrational. Yes. All of those numbers are real. As long as there's not an I, it's real. Not in this level of math, no. Yeah, we're not going to talk about that. Alright, so suppose f is a polynomial function with rational coefficients, and a and b are rational numbers.
So not continuing forever.
Such that, yes, the square root of b is irrational, such that st is such that.
Oh, such that. I thought I said
Irrational is like pi. It goes on forever. If a plus the square root of b is a 0 of f, okay, of the function, then a minus the square root of b is also a 0 of f.
So just to clarify myself again, the A does not compete.
A is just a number. A real number.
A number.
Yes, a real number.
No I.
Real rational number.
Got it.
B is irrational.
Will it have an I?
No, not for this. This is the one that deals with i's. Oops. This is the one that deals with i's. This one deals with irrational numbers.
Yeah. Okay.
This sounds really complicated, but I promise it won't actually be complicated, this part of it. The biggest part is remembering that if you have this, you also have this. Most people forget that. If you see this, automatically write this. If you see this, automatically write this, and vice versa. Correct, because that would just become 2. That would be a number. They're not going to try to trick you that much. I did on a quiz for the pre-cal class recently because I wasn't paying attention. I gave them a number. I gave them like the square root of 9, and they left it as the square root of 9. I'm like, people, it's a 3. Made me a little mad. Sorry. All right, really quick. Let's go back. Okay, I have this one example already worked out. We're going to look at it, and then we're going to do our own examples. This is one of the book examples, but I have it like written out all nice and neat and orderly, so we're going to look at my example. Okay. All right. Yes. Okay, so we are going back to that. Okay, so find all zeros. Okay, notice now it says all zeros. It does not any longer say real. That is the distinction between the last section and this one. Okay? And then I suggest you read the instructions. Okay? So, we find our zeros the same way we've been doing it. Okay, a lot of times they will be nice and only give you a 1 in front of the biggest term. Okay, that's not always true, but most of the time it is. Okay, so you list off all possible ones. Okay, so 1, 2, 7, and 14 are the only possible ones. Then you graph it. You find which ones it looks like there are. Okay, if you were to graph this function, you would see negative 1 and 2. Okay, so you're going to check them. Okay. It's in your book, so you don't really need to. This one's already worked in your book. I mean, if you want to, you can, but I'm not leaving it up super long, so. Alright, so we're going to check it. So, we're doing it by synthetic. Okay, so -1 out here, all your numbers across. You work out the synthetic. If it equals 0, we know that obviously it worked. So then, this is what's different between what we did last section and what we're doing now. Okay? Over here, you need to write out x is equal to -1. Okay, so you need to write the factor that x plus 1 is equal to 0. Okay? Yes. Yes. So I usually write x is equal to -1, and then I move it over just so it doesn't get lost in the confusion of, like, forgetting to change the sign. But if you just remember, I just need to flip the sign, you can do that. Okay? Now, this is where it's different. Normally, we just take the number and we plug it back into the original stuff up here, blah, blah, blah. You don't want to do that, because we need this completely factored out, basically, because otherwise you won't find all of them. So now, the numbers that are left here, you bring down. Yes. So if you get this first step wrong, you're done. So, you have to be very careful with your math, okay? Because if not, you're going to struggle, okay? So, you bring all these numbers down, but not the number that's in the box at the end. Okay, so remember this was x to the 5th out here, this term, so now this is technically x to the 4th. Okay, so you bring all those down and you try the other number. So then, after I do synthetic, it comes out to be 0. X is equal to 2, so x minus 2 is equal to 0, so that's one of the other factors. So now I'm left with, this was a 4th term, so this is now a cubed term. So I've rewritten it, x cubed minus 3x squared plus 3x plus 7. Okay? So now I start to wonder, okay, I didn't see any other zeros, but I'm not done. So I'm going to try -1 again. Okay, and part of this, looking at the graph, would probably help you see which one to try again. But you're going to try -1 again. In this case, it worked. It gave us another 0. Yes, but it could be a double 0 there. Because we need 5. There's going to be 5 because this was an x to the 5th problem. Most likely, if we looked at the graph, I'm just not graphing this one because we're going to spend so much time on these problems, like doing them. You would see that there's something happens there on the graph, which I'll show you like when we look at them to kind of like look and see. That'll indicate to you that it's probably a double. Like if you had x plus 1 squared, then it would be a double 0 there. It would be a triple 0 at -1. Okay? So now this is down to x squared minus 4x plus 7. Okay? That's where we're at now. Now, we don't know off the top of our head any other zeros. We can't factor this. Sometimes you can. We can't factor this. That's where the eyes come in. Okay? So, what I need now is the quadratic formula. Okay? Behind Ariel's head is the quadratic formula if you need a refresher. Okay? You'd fill in the quadratic formula. And then the numbers that you get out after you work your way down, okay, there ends up being a negative inside, so you pull the I out, blah, 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 cancel stuff out. You're left with 2 plus or minus I root 3. Pulled out a 2 from everything, and the 2 went away. Or, well, you pulled out a 2 from the top stuff, top and bottom 2's canceled. You got rid of it. Yes. Okay, remember it has to be in both pieces to be able to pull it out. Okay, usually it's nice they don't leave you with fractions. Normally they give you nice ones that cancel. Somebody worked out all the problems and made sure that they're nice. Okay, so then you set these pieces in here in parentheses. Okay, x minus that. Okay, and then inside it's the the plus stuff. Moving it all over, blah, blah, blah. You get all the different little factors. So then all your zeros, it's asking you to list the zeros. So it's -1, -1, 2, 2 plus I root 3, and 2 minus I root 3. Okay. Once we do an example of our own that's not worked out, this will make more sense. Because if you had a factor like x plus 1 and you square it, there's a double zero there. Yes, Brooke. Yes. No. There will not. So that's why I'm taking it off. That's true, because they cannot hear Lorelai's, why are you taking your sweatshirt off? Alright, let's start with some easy examples. How about that? That make you happy?
Yeah.
Okay.
No, because when you say easy and then I don't get it, then I'm like, wow, you dumb.
If you don't get this part, you're going to struggle.
Thank you.
Alright, these first problems literally say to identify
How many solutions?
the number of solutions
Ask the question to death.
or zeros.
I'm pretty sure I asked the same question 4 different ways, but I got the
Alright, number 4. 5y cubed minus 3y squared plus 8y is equal to 0. How many solutions are there? 3. Okay, because it's y to the third, so there are 3 solutions.
What is worse? I read the problem number 4. I'm putting the next one, nobody speaks.
Alright. H of x is equal to negative x to the 12th plus 7x to the 8th plus 5x to the 4th minus 8x plus 6. How many solutions are there? 12.
Oh my god, I go, woo!
Okay? If you actually had to do this problem, this would be really unfortunate.
I'd be like, yeah, you can take the 10 points off.
I'm usually not that mean. Usually.
You know, in case the guys listen, I'll make them mad. I'm ready for one of the big ones where I do the first part twice.
We're going to hope we get through one problem. Let's just hope that right now.
Is that hard?
They're just long.
I'm not having a tendency to do a problem that long.
They're really not. They just seem like it. All right.
Jennifer, I am ready to either A, be smart, or not.
To graph it. All right. These next ones, find all zeros. Okay, notice it says all zeros. Not real. It just says all zeros of the polynomial function. All right. Again, this is very important. If you're missing a term, you put in a 0. It will throw your whole problem off, and it will not be pleasant. The number of people that forget that.
Yeah. I feel like you put the 0 in the wrong spot.
That too.
And then I had to redo it. So then why? I've not done
14. F of x is equal to x to the 4th plus 15x squared minus 16.
Okay, so we are missing a term. I'm making that statement. We're missing the third one. Yeah. Right.
You're missing 2 terms.
I lied. We're missing 2 terms.
Okay, so good. Maybe we should make a note of that so we don't forget. Okay, you might even want to mark which ones you are missing. Maybe even put them in where they're missing.
And highlight them.
Okay, so now I first need to do the method that we've been doing for, you know, a week now. So, okay, so I'm going to have 16, you know, I'm not even going to do it in red, just so that is just very, very noticeable that we're missing things. Okay, so 16 over 1. Well, okay, that's not true. You don't have to have an even number. Because if I had 4 on top, I'd have 1, 2, and 4. Because I don't write them twice. Alright, it's 1 and 16, okay, so I'm going to write the 1. 2 and 8, so I'm going to write the 2. 4 happens twice. Okay, so I only need to write it once. Not necessarily, no. Not in this part. It would have to be repeated on the graph. 8 and then 16 all over 1. I'm not going to rewrite them all since it's just over 1. Alright, so now you need to put this function into your calculator. I'm going to try to, like, keep everything up here. Okay, I have lots of stuff in my calculator. Yes. No. Okay, you're going to, again, make sure you do the Zoom 6 first. Okay? Or we could have an imaginary one, or we might have to do the quadratic formula. Who knows? At this point, we don't know. So Zoom box and make sure you can see where these numbers are. It doesn't really matter. I just go a little bit below and a little bit above so I have some space to deal with. No. If they're whole numbers, no, but if you've got fractions, you do need to. That's how you want to do it? That's fine. I don't care. No. I would wait until we have one because it's going to be hard for me to explain it without actually having an example that does that. After this one, we definitely won't have time today because we're not even going to finish this problem today. We'll do 18 and I'll show you. Oh, like 5 minutes. Alright, so we said -1 and 1, okay, are ones that we think, whoop, not that. -1 and 1. Okay, it really doesn't matter which one you start with. -1 or 1. -1, cool. That's where it is on the graph. Alright, so we're starting with -1 and we're setting up our synthetic. So 1, 0, 15, 0, -16. Okay, so let's work the synthetic. Somebody tell me what I need. Okay, so x is equal to -1, okay, or x plus 1 is equal to 0, okay, would be the factor. Okay, the reason I'm writing both is just so you get used to it, because some of them it's going to want you to write the factor, some of them it's going to want you to write the zeros. This one's asking for zeros, so we need this. Just so we get in the habit, it's just good to write both. Okay, so we've used -1, so we're going to obviously go down and use 1 now. We're using these numbers instead, because it's what's left over, and it's going to make your life easier. Because otherwise, you're not going to get the rest of the zeros. Because we know that we know there has to be 4, and right now we only have 2.
Really, would it matter, like, even in the long run, it doesn't matter which number you choose to be first?
If you have a fraction that you can tell is going to cancel with the stuff that's originally there, you might want to use the fraction first. But in technicality, it doesn't matter. It just might make your life easier. So 1 with 1, -1, 16, -16. Okay, so x is equal to 1, and then the factor would be x minus 1 is equal to 0. Okay, so now I have, just to go back and just make sure we understand where we started. Okay, this was x to the 4th the first time, meaning that then the next time when we rewrote it, this was x cubed. So now this is x squared, so I now have x squared, plus 16 is equal to 0. Huh? So we don't need the quadratic formula, but I'm going to caution you, this is not a special type, even though it looks like it. Okay? So this is x squared is equal to -16. So x is equal to the square root of -16. Okay, technically plus or minus, that's how we're going to get both. Okay, x equals plus or minus 4i, so our other factors then are x is equal to 4i, or x minus 4i is equal to 0, and then x is equal to -4i, so x plus 4i is equal to 0. Again, for this problem, it asks for zeros, not factors. Whoa, too far. So I need all of these here. Okay, so you're going to just list them out. -1, 1, -4i, 4i. It really doesn't matter what order. Usually your book will list the ones that have i's or radicals last. Okay, so these are all your zeros for this problem. So we did get through the problem. See, that wasn't too bad. Okay, tomorrow we're going to start with number 18. I'm going to go ahead and make a note of that just so that we don't forget. No, that's not your homework. No. Okay, so this is a problem we'll start with tomorrow. Or, yeah, tomorrow's Friday, right? Yeah. Tomorrow, we'll start with tomorrow. Yeah.